This section introduces the mechanical properties with respect to stress-strain diagram of materials. When an external force acts on a material, stress is generated, and then strain is generated. So far, we have argued about the behavior of material structures, which are exposed to external force in tension or compression. We also have solved several problems by assuming that the relationship between stress and strain basically follows Hooke's law. However, in reality, materials do not behave as such. Materials normally do not follow Hooke's law, especially when large loads are applied. When a material is subject to large stresses, the relationship between stress and strain is not proportional. Within the initial small region of deformation, the stress and strain are proportional. However, as the magnitude of stress increases, the relationship collapses. The slope, which is Young's modulus, gradually changes, and finally, the material breaks off as shown in the diagram. This diagram is called stress-strain diagram. When a material is subject to an increase of force, it eventually breaks. Stress cannot continue to increase. The same is true for strain. When we use a material as mechanical parts, for example, we need to consider its capability of stress and strain. So, we need to experimentally verify a curve of the relationship between stress and strain of a material. Without knowing the curve of materials such as steels, resins, and others, we cannot guarantee the quality of structural and mechanical parts. So, we first need to measure the material characteristic using a material testing machine shown in this illustration. The test is performed by clamping the upper and lower part of a material test piece and pulling it. Then, we measure the load and elongation and derive the relationship between stress and strain.